Last part asks us to complete the table below that compares the features on distance, time and speed time graphs. So we're thinking, if we see this feature on the distance time graph, what does it represent? So I'll try and do a little sketch of each one as we go. So if we have a distance time graph with a straight horizontal line, it could of course be at the bottom as well. It doesn't make that clear, does it, in the way it's worded? This means something that at multiple times is at the same distance. So we describe this as being stationary. Lots of other words for stationary, but generally we go for stationary in physics. If, on the other hand, this was a speed time graph, then what this means is that each time that's occurring, so over a length of time, the speed was always one set value. So on a speed time graph, we'd say this is a constant speed. The constant speed could be 0, but 0 is still a constant speed. Let's get rid of that. And that. Second one, a straight diagonal line. So we could draw a straight diagonal line in like this. On a distance time graph, this means that in equal intervals of time, we're traveling the same distance. That implies it is going at a constant speed. Whereas for our velocity time graph, or speed time graph, straight diagonal line means the speed keeps changing. So each time we look, the speed has changed, but again, it's gone up by even steps. So we describe this as a constant acceleration. Next one says curves show. So on a distance time graph, there's lots of different curves I could draw, curving either way. Maybe if I draw one of each. We're not too worried about which way it's curving. So on the distance time graph, initially it was steep and it's getting shallower, or initially it was shallower and it's getting steeper. So in both cases, the change in the gradient of the line implies there is a changing speed. But if we were to switch this to a speed time graph, again, we know that whereas previously there was a constant acceleration, now there is going to be a changing acceleration. There is a name for this idea in physics. It's called the jerk. So if you imagine when you go from a zero acceleration to being accelerated very quickly, the feeling that you might feel is that you're sort of being jerked by, if you imagine getting on a roller coaster when it starts moving, that sensation is the change in acceleration rapidly. Next one, the area under the graph. Well, the area under the graph doesn't show anything on a distance time graph, so let's block that box out. We've just had lots of practice seeing that the area under a speed time graph shows the distance traveled. And the last one, the gradient of the line is equal to, well, we should have picked this up from these parts up here. The gradient of the line on the distance time graph gives us the speed at which the thing is traveling, whereas on the speed time graph, it gives us the acceleration of the object.